Okay, the study guide number one is where you have to find the vertex, domain, and range, the intercepts, and the increasing, decreasing of the parabola. So number one is, so to find the vertex, it's simply x is equal to negative b over 2a, which is negative 4 over 2 times 1. And so this is 4 over 2, which is 2. And then you substitute that back into your original equation. So f of 2 is equal to 2 squared minus 4 times 2. And that's 4 minus 8, which is negative 4. Now, so your vertex is 2, negative 4. Your domain and range. So for a parabola, your domain will always be all real numbers. And then for your range, think about it. This parabola opens upward because a is positive. And if your vertex is at 2, negative 4, and it opens upward, then your range is from the vertex on up. So the range here is all y, such that y is greater than or equal to negative 4. For part C, the intercepts are pretty straightforward. For the x-intercept, you want to set y equal to 0, and for the x-intercept, for the y-intercept, you set x equal to 0, and the x-intercept, you set y equal to 0. So for your x-intercept, it's 0 is equal to x squared minus 4x. You factor out an x. And so your x-intercepts are 0 and at 4. So 0, 0, and at 4, 0. And your y-intercept's pretty straightforward. You just plug 0 in for x. And your y-intercept is just f of 0, which is equal to 0 squared minus 4 times 0. So that's 0. And then letter D. So if this is your parabola, you're decreasing until the vertex, and then after the vertex, you're increasing. So your decreasing is when x is less than 2, because remember, this point is 2, negative 4. And then it's increasing when you're greater than 2. So that is number one. Number two is done the same exact way, except there are a couple things different. First one, it being a negative parabola. So the second one is f of x is equal to negative 3x squared plus 3x minus 2. So your vertex is, you can do x is equal to negative b over 2a. So that's negative 3 over 2 times negative 3. And so if you do the math here, you get negative 3 over negative 6, which is 1/2. Okay. And then you're going to substitute the 1/2 in. So f of 1/2 is equal to negative 3 times 1/2 squared plus 3 times 1/2 minus 2. So this is negative 3 times 1/4 plus 3/2 minus 2. I would just change everything to a common denominator, where you have negative 3/4 plus 6 over 4 plus 8 over 4. And so you get, minus 8 over 4. So you get negative 5/4. Okay. Now, so your vertex here is 1/2 negative 5/4. So part C, or part B, remember that your domain is always all real numbers. Your range, so this is a parabola that opens downwards. So that means your vertex is the maximum point. So the y values will be this y value and everything less than that. So your range is all y's, where y is less than or equal to negative 5/4. Now the intercepts for this one are, so let's do the y-intercept first. The y-intercept's easier. You set x equal to 0. And then so if you do that, you get negative 2. For your x-intercept, now, some of you might have already seen, but if this parabola opens down and your vertex is at 1/2 negative 5/4, visually you would know it doesn't have any x-intercepts. But if you didn't catch that and you were doing this problem, you would set the function equal to 0. Okay. Obviously, it's easier when your leading coefficient is positive, so I'm going to multiply both sides by negative 1. So I have 3x squared minus 3x plus 2. And when you see this, you were trying to factor it, but it can't be factored. So next thing you would do is you would do, okay, I could use the quadratic formula to find my x-intercepts. And so this would be 3 plus or minus the square root of 9 minus 4 times 3 times 2 all over 6. But you already see that the under the square root is negative. So this won't have any x-intercepts. So no x-intercepts here. And then for letter D, so remember, if your parabola opens this way, then it's going to be increasing until your vertex and then decreasing after. So for letter D, you're increasing when x is less than 1/2, and you're decreasing when x is greater than 1/2. So that's your parabola question. Now, the next question is visually looking at a graph and determining the inequality there. So for number 3, you had the graph where and if you look at the graph, this point is -1, -3, and this point here is -4, -6. Now question, and the linear function is f of x, and the quadratic is g of x. So the first question they ask is, when is f of x greater than or equal to g of x? So what they're asking for is, when is the line, remember f of x really just stands for y. When are the y values of your line greater than or equal to the y values of your parabola? Well, here it's kind of obvious, because after this point, after this cutoff point, the line will always be above the parabola. So I know that x is greater than or equal to -1. However, there's another part, so we kind of split this into the intervals where they intersect. Past this intersection point, the line is also above the parabola. Remember, the parabola is going to keep going down this way, and the line will always be above it. So this is or x is less than or equal to -4. Be aware that the question says greater than or equal to, so your inequalities here should be with the equal sign underneath. Now letter B is asking for when is g of x greater than f of x. Now g of x is your parabola and it's greater than the line here. The parabola is above the line. So this is simply that x is between -4 and -1. And once again, the inequality symbol here is a greater than, so it does not mean greater than or equal to, so do not include the equal to's underneath the less than sign here. Now we go to the back of the first page, number 4. Now number 4 is this revenue equation. So if you remember, the revenue will be the cost of the items, which is the price, times the number of units. And so your formula here is R is equal to XP. Not going to see that. But R is equal to XP. Now, so R is equal to XP. Now, you have what P is equal to, and P is equal to -1/3 x plus 100. Let me write that. So if I just distribute the x in, your revenue equation is -1/3 x squared plus 100x. Now for letter B, they want the domain for this. So remember, when you're selling stuff and you're trying to find revenue, you cannot sell negative items and you can't have a negative or zero price. So there's two restrictions here. I know x is greater than or equal to 0 because that's the number of items has to be greater than or equal to 0. And since x is my variable in the revenue equation, we could just leave it like that. Now the next restriction though is my price has to be greater than 0. Now since there is no p in this revenue equation, we have to go back to our original p equation because revenue is in x, and if you want to find the domain, it has to be in x. So p is greater than 0, but we have what p, the relationship between p and x. So I'm going to make -1/3 x plus 100 greater than 0. And then once you you just solve this inequality. So you would do -100, -100, and then -1/3 x is greater than -100. Multiply both sides by -3. Remember, when you multiply both sides by a negative, your inequality symbol switches. So this is x is less than 300. And now we could all put that together. So your domain is all x, where, remember, if we flip this around, this is 0 is less than or equal to x, less than 300. And that is your domain. Now letter C is pretty straightforward. C, they just want to know what the revenue is if 100 units are sold, so you just substitute 100 into your revenue equation. You could kind of see that on the answer guide, and your answer should be 6,666.67 cents. So I'm not going to go through that one. Letter D. Letter D, what quantity x maximizes revenue? Well, since revenue is a quadratic, then we can we know it's this type of quadratic. If the x value represents the number of items, the y value represents revenue, so we just need to find the vertex. the X is the quantity X that maximizes the revenue, and the maximum revenue is the Y value. So for letter D, it's just X is equal to negative B over 2A. We're using a revenue equation here. So that's negative 100 over 2 times negative 1/3. And that's equal to negative 100 over negative 2/3. Remember, when you divide by a fraction, it's just multiplying by the reciprocal. So this is negative 100 times negative 3 over 2, 300 over 2, which is 150. So 150 units maximizes the revenue. Now, they want to know what is the maximum revenue. So once you get this as your answer for the X, just plug it back into the revenue equation. And once you put that into your calculator, you'll see that your answer is 7,500. And then for letter E asks what is the price that will maximize revenue? Well, if you know the relationship between P and X, so since we already found the X that maximizes revenue, which is 150, we substitute 150 into the price equation, and that will give us the price. So letter E is simply P is equal to negative 1/3 times 150 plus 100. And so that's negative 50 plus 100. So your price should be $50. Okay. Now number 5 is also a question about maximizing area, and that is a farmer with 10,000 meters of fencing wants to enclose a rectangular field and then divide it into 2 plots with a fence parallel to one of the sides. What is the largest area that can be enclosed? So this one's a little more difficult than the homework problems that were assigned to this. But this is not too bad. The only thing that you add is you add another part of the fence that's parallel to the other 2 sides. So you would have, if this is X, and if this is X up here, this would be W, W, and W. Okay? You have that one extra strip of fence that's right here. So in this question, the perimeter is 10,000 meters because that's how much fencing he's going to use. So you just have a perimeter equation, and that's 2x plus 3w is equal to 10,000. And then I also want to know the max area. That's what the question's asking for. So I have an area equation. Area is equal to xw. Now, what we should do, though, is solve the perimeter equation for one of the variables so that we could substitute it into area. So that area will be all in one variable. So what I'm going to do is I'm going to solve for x. And so this is going to be 2x is equal to 10,000 minus 3w. Divide everything by 2. Okay. And what I'm going to do, I'm just going to switch the variables around. So x is equal to negative 3/2 w plus 5,000. Okay. Now that I have that, I just plug it into this equation. Okay? So this is going to go into here. And then so the area will be negative 3/2 w plus 5,000. And this is going to be all multiplied by w. We bring the w in. And so you have an area equation of negative 3/2 w squared plus 5,000 w. Now, since this is a parabola, we could find the largest area by just doing our negative b over 2a. And you should all know how to do that. And if you look at the notes that I put, the solution is there. Okay, now number 6. So number 6 is about end behavior. And end behavior is a pretty a concept that's pretty straightforward. So if you have and they're asking for your end behavior, remember end behavior is really the term, the highest power term. So here, if you multiply this out, this is x to the third plus 5x squared. So your highest degree term is x to the third. So your end behavior, and make sure you write it as a function, is f of x is equal to x to the third. Okay? Make sure you write that f of x there. Now for letter B, for the end behavior, so I have g of x is equal to negative 4x to the third, x plus 1, 2x minus 1 squared. Now, you don't have to multiply all this out, because that would be way too much work. Because remember, when you multiply it out, the highest degree term will always be the first terms multiplied together. So I'm going to multiply this, I'm going to multiply the x, and I'm going to multiply the 2x, but remember, it's being squared, so I have to square 2x. So this is negative 4x to the third times x, and 2x squared is really 4x squared. And so my end behavior is negative 16x to the sixth. Now number 7 is about the polynomial. And looking at the graph, and then determining the equation. So here's your graph. And it looks like it has a 0 at negative 1, a 0 at 1, and then a 0 at 4. Okay? So 4, 1, negative 1. So if we were to write this equation, we know these are zeros, so we could write the factors. Now remember, when we write a polynomial equation, there will always be a coefficient, which we don't know what it is. So we're going to put a there. The 0 of negative 1 has its x plus 1. But if you look, the graph touches the axis, which means it's going to be of even multiplicity. And I don't know if the directions say it, but it should be in the lowest degree. So we're not going to put to the power of 4, we'll put to the power of 2 here. Then I know I have another 0 at 1, and I have another 0 at 4. So that is your polynomial equation. However, we don't know what the a is, so we're going to find that. And we have to find the a here. We can't make it 1 because there is a restriction here, and it has to go through the point 3,8. So once we have, since we know it goes to 3,8, we're going to make that our x, make that our y. So it's 8 is equal to a, 3 plus 1 squared, 3 minus 1, 3 minus 4. So this is going to be 16 times 2 times negative 1. And so 8 is equal to negative 32a. Divide both sides by negative 32. And so a is equal to negative 1 over 4. So when you write the final polynomial equation, you just replace the a here with negative 1/4. So y is equal to negative 1/4, x plus 1 squared, x minus 1, x minus 4. Number 8. Number 8, you have a polynomial with degree 3, and it has zeros at 4 plus I and 6. So remember, if you have a degree 3 polynomial, and the zeros are at 6 and 4 plus I know my other 0 because of the conjugate pair theorem. If I have 4 plus I is 0, 4 minus I must also be a 0. So what we're going to do is we are going to, since these are the zeros, we could write the factors as y is, we're going to put an a here, but obviously the a will be 1. There's no restriction here. But we will put x minus 6, x minus this 0, which is 4 plus I, and then x minus 4 minus I. Now, on the study guide, I kind of just shifted these parentheses over, but technically that's not correct. What you're supposed to do is you are supposed to distribute that negative in. I know it ends up being the same thing, but we should be mathematically correct. Remember, we take away the a because it's not there. So what I'm going to do, I'm going to distribute the negative in. And then after I distribute the negative, then I could put parentheses around the x minus 4s. And so now we have a conjugate pair over there. Okay. So I have x minus 6, and then this is going to be x minus 4 squared minus I squared. And then so this is x minus 6. And then if I factor this out, this is x squared minus 8x plus 16. I squared is negative 1, so minus negative 1 is plus 1. So I get x squared minus 8x plus 17. And then I just distribute this out, and I get y. So remember, multiply the x first, so I get x times x squared is x to the third. X times negative 8x is negative 8x squared, and x times 17 is plus 17x. Then I multiply the negative 6 in. This is minus 6x squared plus 48x minus 102. And then you just combine your like terms and you get the answer that's in the notes, which is y is equal to x to the third minus 14x squared plus 65x minus 102. Okay, so for number 9, we want to find the complex zeros of f of x is equal to 4x cubed plus 4x squared minus 7x plus 2. I said on the notes that you don't have to show me the PQ stuff, just because for saving time on the test. So what you should do on this question is just go ahead and graph it. Okay. And once you graph it, just see where 0 hits, where the graph intersects the 0. Now, however, so if you graph this on the graphing calculator, you'll see that the graph goes through negative 2. So I know there's a 0 at negative 2, but I do want you to double check that it is a 0 since we didn't do the PQ stuff. So what you want to do first is graph it, and then I find a 0 going to be at negative 2. Once I find that's my 0, I'm going to substitute it into the equation. Watch your signs in all of this. This is negative 32 plus 16 plus 14 plus 2, and that equals to 0, which means that we did find one of the zeros. Now remember, the next step after this is to do synthetic division with the negative 2. So negative 2 goes on the outside, and we put the coefficients. Remember, if you're missing a coefficient, you have to put a 0. But here we're not, not coefficient. If you're missing a power, you have to put a 0. So this is 4, 4, negative 7, 2. We drop the 4. 4 times negative 2 is negative 8. This is negative 4. Negative 4 times negative 2 is positive 8. This is 1. 1 times negative 2 is negative 2, and that's 0. So what I have is, I know one of my zeros is x plus 2. And then my other, this is going to be my equation here, which is 4x squared minus 4x plus 1. And then, so we could factor this. And so your zeros here are negative 2, and x is equal to 1/2. By the way, if you can't factor this, you would need to use the quadratic formula. And it's okay to get complex zeros because we are finding the complex zeros. That's what the question's asking for. So please look over your notes to write the function with the complex zeros. The one on the test will be something where I think you have to use the quadratic formula to find your complex zeros. So this is what the answer is. It wants the zeros, and it wants the factored form. Now, number 10. So I know a lot of you still have issues with the graphing. So let's go through this problem and see how to graph this function. Okay? So number 10, you have r of x is equal to x plus 2 over x, x minus 2. It's already in reduced terms. So let's find the intercepts. The y-intercept is when x is equal to 0. But if x is equal to 0, the bottom would be 0 and it would be undefined. So there are no y-intercepts. The x-intercept, remember we just set the top equal to 0. So 0 is equal to x plus 2. Your x-intercept is at negative 2. Okay? And this is a multiplicity of 1, which means you just cross the axis. Now the next step is to find your vertical asymptotes. So I'm going to number these in the steps that we did the notes in. So for vertical asymptote, it's when the denominator equals 0, so x is equal to 0 and x is equal to 2, or your x-intercepts. Your vertical asymptotes. These are both a multiplicity of 1. Now, horizontal asymptote, you have to kind of remember. So the degree on the top is less. So your horizontal asymptote here is y is equal to 0. Now remember, one of the steps you have to do is you have to see, can your horizontal asymptote intersect your graph? And your graph will intersect, when two graphs intersect is when the two graphs are equal. So if your horizontal asymptote is 0, we make it equal to x plus 2 and x minus 2. And I know it's going to be the same as our x-intercept here. But we have to do this step because remember, some other times your horizontal asymptote will not be 0. So if I multiply both sides by x minus 2, I get 0 is equal to x plus 2. And I know from here, I know my horizontal asymptote will cross at x equals negative 2. So I know at x equals negative 2, I'm going to cross the horizontal asymptote. Okay. Now here comes the part where everyone is kind of struggling with a little bit. Here's your graph. I know I have a vertical asymptote at 0 and at 2. Okay. I know I have a horizontal asymptote at 0. So the next thing to do, and I know I have no y-intercept, but I have an x-intercept at negative 2. And remember, I also cross my horizontal axis at negative 2. So it's going to cross here. Now, we have to kind of determine how this graph looks like. So what we're going to do is we're going to plot some test points. So what I'm going to do is I'm going to check this interval first. And then kind of look like that over here, going through 3 and 5/3. Okay? Now, this vertical asymptote is odd multiplicity, so I know it's going to go down here. I know that part of the graph is going to be pointing down. Now, what I should do is plug in a number like 1. If I plug a number in like 1, I get that it goes through negative 3. Okay, so it seems like if you're confused of what to do here, and you're like, oh, I don't know what to do because there's an asymptote, but there's a point, do this interval next, okay? And then we could come back. When I plugged negative 1, went through 1/3. That was my y value. And since I know it crosses the asymptote here, I know my curve is going to come down like this. So that means we're going to cross, and it's going to go like that. Okay. So now this points up, so that means here, since the vertical asymptote is of odd multiplicity, this part has to point down as well. And so now you see, okay, points down, goes through that point, it's going to be a parabola. And that's how your graph should be. So you I plugged 3 points in each interval to see where the graphs will end up being at. Okay. Now, number 11. Number 11 is another graphing question. So remember, the first part of these graphing questions is to always factor and try to put it in lowest terms. So this is x squared minus 4 over x squared minus x minus 2. So if I factor this is r of x is equal to x plus 2, x minus 2, difference of squares, and then on the bottom, x plus 1, x minus 2. And I know my domain is all x, but x cannot equal negative 1, or x cannot equal 2. So what happens is the x minus 2's, those factors will simplify. And so I have r of x is equal to x plus 2 over x plus 1. Now your y-intercept is when x is equal to 0. So your y-intercept is r of 0 is equal to 2 over 1, which is 2. So I know it goes to the point 0, 2. For your x-intercept, you set the numerator equal to 0. So 0 is equal to x plus 2. And so your x-intercept is negative 2. So we're at negative 2, 0. Now, once you do the intercepts, the next thing is your asymptotes. So your vertical asymptote is when the denominator is equal to 0, so and it's of the reduced form. So x is equal to -1. Your horizontal asymptote is the degrees are equal here. So I take the coefficients of the leading terms, and that's 1 over 1. So your horizontal asymptote is y is equal to 1 over 1, which is y is equal to 1. Now, remember, you have to see, do I cross the horizontal asymptote? So what I'm going to do is I'm going to make 1 equal to the rational function here, is equal to x plus 2 over x plus 1. I multiply both sides by x plus 1, and I get x plus 1 is equal to x plus 2. The x's cancel and 1 is equal to 2, which is an inconsistent equation, which means we do not cross the horizontal asymptote. Okay? So this graph does not cross the horizontal asymptote. So we have all the information, and so now I'm going to go ahead and graph it. Okay. So if I graph it, I know I have a vertical asymptote at -1, and that's my only vertical asymptote. So my horizontal asymptote is at y equals 1. So what I'm going to do is I'm going to plot some test points. Okay. I know also that I have intercepts at 2, y equals 2, and I have an x-intercept at -2. So without even doing test points, you should know your graph kind of looks like that and looks like this. Because since we don't cross any of the asymptotes here, and I have a point on the negative and a point on the positive with an odd multiplicity, I know this is going to point up, not cross, and it's not going to cross here as well. But you should put a test point. Let's just do the test point at x is equal to 1. And if x is equal to 1, I see that I'm at 3/2, which is 1.5. So yeah, it falls in line with what I thought it was going to look like. Okay. However, one thing that we need to take into account is if you go back to the original function, there is a hole. Because remember, in your original function, you had x minus 2 on the denominator, but we crossed it out. But the domain, you still can't have 2 in your denominator. So at 2, you will have a hole. Okay? And you can actually know where the hole is, the y value of the hole, by plugging 2 back in, x equals 2 into the reduced form. And if I substitute x equals 2 in the reduced form, you have the inequality x minus 2, x minus 1 over x minus 3 greater than or equal to 0. So you have, remember you need to do the zeros of both the numerator and the denominator. So your zeros are 1, 2, and 3. Remember, your denominator will always be an open hole. Greater than or equal to means the other zeros are the closed dots. And if we do the intervals, if I plug a number like 4 in, everything will be positive. If I plug in 2.5, this one is negative, the other two are positive. If I plug in 1.5, I have 2 negatives, and 1 positive. So that's going to be positive. And then if I plug in a number like 0, everything's negative. Negative times negative times negative, or negative times negative divided by a negative is negative. So they're looking for greater than or equal to 0, so I'm looking for my plus signs. So I just go ahead and write the interval here, all x, that 1 is less than or equal to x, less than or equal to 2, or x is greater than 3. Remember, greater than 3 because we have an open dot there. Now, number 13 is done the same exact way. However, I want to do a problem that's not on the study guide. And I want to do a problem that looks like this because you'll see it on the test. So remember, if you have this type of inequality, you have to bring everything to one side. So x plus 1 over x minus 3 minus 2 is less than or equal to 0. Then you need to find a common denominator here, which is x minus 3. And I'm just going to break it. I know most people, I've been skipping this step, but it's just so people who are kind of lost a little bit know what's happening. I'm really multiplying 2 by a common denominator of x minus 3. And remember, since I'm missing an x minus 3 on the bottom, I have to multiply by x minus 3 on the top. And now since they're common denominators, I could just subtract the numerators. So this is x plus 1 minus 2x minus 3 over x minus 3. Okay. And usually I've been just skipping to that step. Okay, now we should all know what to do. We just distribute. So this is x plus 1 minus 2x plus 6 over x minus 3. And then so I get negative x plus 7 over x minus 3 is less than or equal to 0. Okay. And then so here I know that my zeros are going to be at 3 and 7. And so now I just plug in my numbers. If I plug in 8, I get negative 8 plus 7, that's negative. And 8 minus 3 is positive, so this is negative. If I plug in a number like 4, that's positive, so the middle is positive. And if I plug in a number like 2 or 0, that's positive, that's negative, this is negative. Remember, the 3 is an open hole, and the 7 is a closed dot. So now they're asking when it's less than or equal to 0. So I'm giving them these as my answer. So this is where x is less than negative 3, or x is greater than or equal to 7.